Okay, good morning, everyone. So we have waited for some amount of time. That's fine. People will be joining in our session, actually. No problem for that. Okay, before starting the session, I want to thank you people, actually, because it's a Sunday. I understand and it's not time. So thank you for giving me the time and attending the seminar. Okay, so that's the thing, actually. So this seminar is all about managing the Kubernetes secrets. Okay, so if you are new to Kubernetes, it might be something difficult for you. Okay, please do remember that. Okay, managing secrets in a centralized manner and secured manner using AWS Secret Manager. Okay, how we are going to do that? Okay, that's what the seminar will be. Actually, the topic of the seminar will be. Okay, and before starting the seminar, I want to introduce myself. Okay, I am Shiva. So I have overall 8+ years of experience. Uh, yeah, I work as a senior DevOps engineer in one of the a company. Okay, so I hold certifications from AWS, Kubernetes, and Terraform. So this is a short introduction about myself. Okay, that's the thing. Okay, before starting the seminar, I want to share my screen and I want to list out all the things that are that how the seminar goes, actually, how today's seminar goes. And the other parts, actually, let me go here, paint. Okay, let me open file, new. Okay, the seminar is managing secrets, Kubernetes, Kubernetes secrets with AWS secrets manager. Okay, we are going to use or we are going to leverage secret store CSI driver in order to achieve this. Secret store CSI driver in order to achieve our centralized secret management, actually. Okay, how our session goes. Okay, how our session goes, let me put one by one, actually. Okay, initially, in order to deal with this session, okay, you need to have some prerequisites, pre-requirements. Let me put pre-requirements. Of course, you should have an AWS account, and you should have an like EKS cluster running, EKS cluster running, right? And you should have some knowledge on Kubernetes. This seminar is not entirely freshers who is joining, like who is very fresh for the Kubernetes, actually. So this requires some knowledge of Kubernetes. These are some of the requirements that you need to have before dealing with this particular seminar, actually. Okay, now the softwares that you need to install before dealing with this seminar. Okay, softwares need to be installed. What are the different softwares that need to be installed is kubectl. kubectl is tool in order to interact with your Kubernetes cluster. Second one is EKS CTL in order to manage your EKS cluster. Okay, you need to have Helm installed on your machine. So all these tools that need to be installed on your machines in order to work with this lab. Okay, these are the some of the requirements as well as the software that are required in order to complete this lab actually. Okay, all these things have kept ready before starting the session. Okay, so AWS account I have, EKS cluster, it is running, some knowledge on Kubernetes we have, and softwares are installed on my local machine. Okay, that's what you, these are the pre-requirements that you need to understand. Okay, now how our session goes, how our session goes as part of this today actually, how our session goes. Okay, let me put that one here. How session goes. How session goes. Okay. So first thing we will be discussing on, without this secret manager, how the secrets are. What is a secret first? Okay. What is a secret? Okay. What is a secret? Okay. How we manage secrets without AWS Secrets Manager using traditional Kubernetes secret object. How we manage secrets using traditional Kubernetes KATS secret object. Okay, that's what the second point that we are going to discuss. Okay, so what are the problems that we have? What are the problems that we have if we follow above method in order to manage secret? Okay, in order to manage secrets, above method in order to manage secrets. Okay, that's what the thing is. Okay, now we will be discussing on secret store CSI driver. Okay, so we will be discussing on secret store CSI driver. Now, after this one, we are going to see lab session of managing secrets using AWS secret manager. Okay, that's the thing. After this one, advantages of using secret store CSI driver in managing secrets. Okay, these are the things that we are going to see actually in the today's session actually. Okay, any questions, anyone, please, before starting the session, before the things go on? Any questions? Any questions with the topics, the things that we are going on? Okay, I want to understand from you people. Okay, so how much knowledgeable with the Kubernetes you people are? Do you have some understanding on Kubernetes? Can you comment on that, please?
Hello.
Hello. Yeah.
Yes. For me, I just have some basic knowledge on Kubernetes, but never used it
Mm-hmm.
on production.
Oh, okay. Thanks for that. Thanks for your response. Any other people? Yes. Okay. Okay. Okay, that's fine. Okay, what we are going to do, we are going to start our session actually. Okay, so what is a secret? Secret is nothing but some kind of password which should not be known for everyone who do not have the permissions. Okay, suppose you have some database. Database password is a secret. It should be kept as secret. It should not be known to everyone, right? So some kind of tokens. Okay, we call it as JW tokens. That should be kept as secret. It should not be shown to everyone. It should be kept as personal one. Okay, so that is a secret actually. The text that cannot be shown to everyone, that should be in a personal manner. It should be on your side. Okay, so it should not be discussed with everyone. It should not be shown to everyone. The persons who has the permission only should be able to view the secrets, should be able to view actually. That's a kind some kind of uh, what is that? uh, what's the word we call? Some kind of important information like database passwords or JWT tokens or whatever SSH keys. Okay, so these are all kind of secrets. Okay, that is a secret actually. Okay, how we manage secrets in a Kubernetes, traditional Kubernetes secret object actually. So in Kubernetes secret object, suppose this is our application pod that is running. I am going to take an example of MySQL in this particular lab actually. Okay, I hope am I audible?
Yes.
Yes. Okay. So I am going to take in this lab MySQL as an example because I need to pass the secret for the MySQL application. Suppose this is going to be the MySQL pod that is going to be running in the Kubernetes cluster. In order to run this MySQL pod in the Kubernetes cluster, I need to pass some secret. I need to configure some secret to this MySQL pod. Okay, using MySQL pod environmental variable. Okay, MySQL root password, something called that environmental variable you need to use, and you need to configure that MySQL pod with that secret or the password so that MySQL uses that MySQL database inside this pod uses that password and configures that password actually. Okay, now this is the password we are configuring. How we are configuring in the traditional Kubernetes secret object. So in the traditional Kubernetes secret object, how we are going to configure is something called, we are going to create a Kubernetes secret object in the Kubernetes. See, all these things, some people like you should have some idea on Kubernetes actually. So then only it is good for you. Okay. So there is something called, we are going to create an object, secret object in the Kubernetes cluster, and we are going to put our password in this secret object. Okay, and in the pod manifest file or the deployment manifest file, we are going to refer this secret object. We are going to say this pod, take the secret from this secret object. Okay, take the database password from this secret object. Okay, this is the Kubernetes secret. This is going to be Kubernetes secret. Okay, let me go here. Kubernetes. This is going to be Kubernetes secret. Okay, and in this Kubernetes secret, we are going to store some password, that is database password, MySQL password, MySQL password. Okay, PASS WORD, MySQL password. We are going to store something like this. Okay, in this particular secret, and this password will be referred by our pod in order to configure itself with the password actually. So that's how we deal in present scenario in the present cluster. Okay, so let's first look this scenario, how we deal first. Okay, let's first look this scenario. Okay, now let's do that. Now we have our Kubernetes cluster running. Let me go to my Kubernetes cluster. Okay, if you see kubectl get nodes, we have our Kubernetes cluster running. We have 2 node Kubernetes cluster with 1.25 version. of EKS. Okay, so you can see that here. Now, okay, let me go here, clear the screen, ls. So we have something called ls. So we have some folder called traditional Kubernetes secret store. Okay, that is called cd traditional Kubernetes secret store. Let me go to that particular folder. Okay, you have this one here, scenarios, traditional Kubernetes secret store. You see that we will be creating something called secret object, something like this in the Kubernetes. Okay, so this is a secret object that I am talking about, this one, Kubernetes secret. Okay, this is a secret object that we should create first. Okay, and we are passing the MySQL password in this particular secret object. You can see that very clearly here. We are passing the MySQL password in this secret object. So this is base 64 encoded password. This is base 64 encoded password. If you copy this password, and you can easily decode this one. If echo, okay, something like this, you should put something like this. Okay, command B. You can put base 64 hyphen decode, something like this. You can easily get the password by looking at the manifest file. This is something called manifest file, we call it as. This is a secret manifest file. Okay, now let me apply this secret manifest file to the Kubernetes cluster. If you go here, how to apply the manifest file, Kubernetes secret object to the Kubernetes cluster, kubectl apply -f traditional KATS hyphen secret dot YAML. Okay, I'm going to apply this one. You can see that a secret object is created within the Kubernetes cluster. Where my Kubernetes cluster is running? My Kubernetes cluster is running in the AWS account. That's what you need to remember. Okay, now a secret object is created in the Kubernetes cluster. Now, if you get that secret object, kubectl get secret. Okay, if you want to get, you can see that this is a secret object, and you can edit. You can use this secret object in our Kubernetes manifest files. You can see that here. This is a secret we have just now deployed, right? So what I've told you, this is going to be my MySQL pod. I need to configure my MySQL pod. This is my MySQL database pod, right? I need to configure my MySQL database pod in order to use this password which is configured in the secret. Okay, so now let me go here. Now this is going to be the deployment file of the MySQL. What is deployment and all these things? It's not the session actually. So we will be seeing in our courses something like that. Okay, so in this deployment file, we are taking the password. You can see that MySQL root password from the secret named app secret. What is secret we have deployed? If you go here to the Kubernetes cluster, secret is a secret from which we are taking the password and configuring the MySQL application with the environmental variable, and we are taking the key. What the key means? Key represents the key name in your secret object. You can see that the password. What is the value that you have attached in the base 64 encoded format? The value will be assigned to MySQL root password, and this root environment variable will be configured to the MySQL application. And MySQL application will be using the secret that we have passed here, because we have attached using this particular block using environmental variable section. Okay, you see that here. Now, let me apply this one. Let me apply this to the Kubernetes cluster. Okay, kubectl apply -f traditional KATS. What is the file name? Actually, deploy.yaml. Okay, deploy.yaml. Okay, you can see that a deployment with MySQL is created. If you see kubectl get pods, you see that MySQL container is being creating. You can see that just it's been creating Let's wait for it to fully create. Yeah, you can see that MySQL pod is in running state. Okay, what's the password we have passed? The password which we have set, you can see that base64 encoded password is MySQL. MySQL is the password we have set for our MySQL application, right? So if you go inside this pod, let me go inside this pod, kubectl exec hyphen it pod name, okay, hyphen hyphen slash bin slash sh. Let me go inside this one and let me use MySQL hyphen u root hyphen t, the password which we have set using the environment variable from the secret object, Kubernetes secret object is MySQL, right? That's what you can see that here. When we decode that, what we got? Where is that? It's a MySQL. You can see that here. And let me enter. Okay. Now, what is happened? You have entered into the MySQL database inside the pod. Now, you can execute MySQL queries, show databases, something like this. You can see that all the databases will be listed. Okay. Use MySQL is the database name. Okay. So that database name change it to MySQL and show tables. Okay, these are not related to us, but yeah, tables. Okay, so these are the tables in the MySQL database. Okay, because the database name is MySQL. And the important part that you need to remember is the configuring the password of the MySQL database. How we are configured? First, we have created a Kubernetes secret object in which we have the password, and the password is configured to the Kubernetes application, MySQL application using the environmental variable. You can see that this is how people use to configure the secret or the password in a traditional Kubernetes with the traditional Kubernetes objects actually. Okay, so this is how we do actually. Okay, okay. Any questions with this method actually? Any questions anyone has? Let me come out of the pot. Any questions, please? Is that clear? Yeah, that also works actually. Yeah, you can also use that. Okay. It just I have first entered and I'm using this command. That's it. Huh? Okay. Any questions anyone has? Now, if no questions, let's move further. What are the problems that we have in this case actually? We have deployed the secret and we have deployed the MySQL deployment to the Kubernetes cluster. And what are the problems that we have in this particular case? The problems were something like this. Whatever the manifest files, sorry, I think my screen has been reshared now. I hope my screen is visible again, right? So, uh, okay. So what are the problems that we have in this method actually? The problem is something like this. Problems that we have, the second point is that one only, right? The problems, how we manage secret using traditional secret object we have seen. What is the secret we have seen? How we manage secrets using traditional secret, create a secret object we have seen. This is how we manage actually. We create a secret object with the password and we configure our applications by referring the secret and passing passing the value for that environment variable, something like this. Okay, so that's how we do actually. Okay, now what are the problems that we have if we follow above method in order to manage secrets? Okay, if we follow this method, what are the problems that we have? The problems are something like this. Now, when you create a Kubernetes manifest file, something like this, suppose you created a deployment file. You created a secret file, something like this. Okay, you created a deployment file. You created a secret file. You're never going to put in a real time. You're never going to put this manifest files on your local machine. you will be pushing these manifest files to the GitHub repositories or the version control system. Your organization might be using GitHub or Bitbucket or GitLab, whatever. You will be pushing these manifest files to the to that particular version control systems. Now, if you push these manifest files to the version control systems, right, this password will also be pushed to that particular place, to the version control system, right? In that case, the password will be able to known by everyone who has the access to that particular version control system. Suppose let's think you have pushed to GitHub these manifest files. Okay, this manifest files you have pushed to GitHub repository, right? So the people who has access to that GitHub repository will be able to know the password because it contains the base64 encoded password. People can take this and can easily decode, okay, password using this command, echo something like that we have used right in the like this, echo this encoded password base64 decode. Okay, can easily decode the password using this particular command. Okay, now this is the first disadvantage. Okay, sorry. If you have manifest files in auto managing secrets, so you are going to store the manifest files in the GitHub repository. The persons who has access to that particular GitHub repository will also be able to view the manifest files, and we will also be able to view the password and take the password and get to know about the password details. Okay, so that's kind of a security breach in case of this one. Okay, right. So this is the first disadvantage that we have. Any questions with this disadvantage? Did you people get the disadvantage? The disadvantages are very important in order to understand the advantages. Okay. So did you people got the disadvantage? Yes or no? Okay. 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 The second disadvantage that you are going to have is there is no centralized mechanism in order to manage the secret. What is that? Okay. Suppose you have another application that need to be passed that need to be passed, that need to be configured with the secrets actually. Okay, that need to be configured with the secrets actually. Okay, personal data, something like the passwords. You need to create one more secret object, and you need to configure that secret object to your and as an environment variable to your application, right? So there is no centralized mechanism in order to manage secrets actually. Okay, so there should be a particular place where our all secret need to be put actually, where all the secrets need to be placed, and we need to get the secrets from only that single place actually, so that we can restrict the people to access that particular place. Only few people should be able to view go to that place and get the secrets information and update the secrets information, but not all the people. Okay, in this case, in using traditional secrets Kubernetes secret store or traditional Kubernetes objects in order to managing the secret, there is no centralized mechanism in order to manage the secrets actually. Okay, so and the next disadvantage is the people who has the access to the Kubernetes cluster. Suppose this is a Kubernetes cluster. If I give access to you people, okay, and you can go and you can get the secret kubectl get secret. You can type this command and get the you can type this command, okay, and get the secret name. You will be copying this secret name, and what you'll be doing, kubectl edit secret and the secret name. You will be doing something like this, and you are going to get the base64 encoded secret here itself. The people who has the access to the Kubernetes cluster, the people who has the access to the Kubernetes cluster will be able to get the secret very easily and decode the secret very easily actually. Okay, this is the another disadvantage that we have. So if we keep on talking, there are many disadvantages like this. What we have talked about, the first disadvantage is if you are using Kubernetes secret directly, you will be pushing that manifest files to the GitHub repository. There, who has the permissions to the GitHub repository, will be able to view the secret, the password there of the database in the GitHub files actually, right? So they should not push the passwords directly to the GitHub repositories or the version control systems. Okay, so that's the first disadvantage. And second disadvantage, there is no centralized mechanism in order to manage the secrets using the traditional Kubernetes secret object. That's the second disadvantage. And the third disadvantage, if you have access permissions to get the secrets to your in the Kubernetes cluster, you can fetch the secret object and get the secret value, the password, something like this, and decode that value, and you can use that side of security breach that you are going to have. Okay, like this, we have multiple disadvantages. You know, even if we use traditional Kubernetes secret object, actually. Okay, so because of these disadvantages, we have another method that is called secrets. We have a method with the secret store CSI driver. Okay, we have method with the secret store CSI driver. We have discussed about this, what is secret, and we have discussed about this, how we manage secret using traditional Kubernetes object. And we have discussed about it, what are the problems that we have if you follow the MO method in order to manage the secret. Okay, so different problems we have discussed just now. Right, now secret store CSI driver. Okay, so what is secret store CSI driver? Is secret store CSI driver is a kind of a software. It's a software that will be deployed as pods onto your Kubernetes cluster, which will which will help us to store the secrets centrally, and which will help us to not to create a secret object in our Kubernetes cluster. Because if the secret object is created in the Kubernetes cluster, if you see, if the secret object is created in the Kubernetes cluster, you can easily edit your secret and get the password, and which will secret store CSI driver will directly help us to pass the secret or the password to our pod application pod directly without creating AWS Kubernetes secret object. Okay, if you have AWS Kubernetes secret object created, the secret object is easily fetched and the data will be easily visible for everyone who has the Kubernetes cluster access. It should not be something like that, right? So we are going to install something called secret store CSI driver to our Kubernetes cluster. Okay, let me do with that. Okay, how we are going to install secret store CSI driver to our Kubernetes cluster? Using Helm. Okay, Helm is a package manager of our Kubernetes. Okay, we are going to use the Helm as and we are going to install our secret store CSI driver to our Kubernetes cluster. Okay, before installing secret store CSI driver, you need with the Helm, you need to add the repo of secret store CSI driver to your local Helm repo. Okay, so you should copy this command. Just instead of typing, I'm just copying. Okay, we are going to the Helm repo of secret store CSI driver to our local repo actually. Now let me click on enter. Okay, the secret store CSI driver already exists. Okay, you can see that what are the uh, repos exist on my machine. Helm uh, repo list, something like this. You can see these are the different repos that are already existed on my machine actually. So if those are does not existed, you can use this command to add secret store CSI driver to your local repo list, Helm repo list actually. Okay. Now, after adding that secret store CSI driver to your local repo list, you can install secret store CSI driver using Helm. I am going to install this to kube system namespace. You see that here? This is the release name that we call it as. This is the repo, and this is the namespace that we are going to install to the actually secret store CSI driver 2 actually. So let me copy this Helm install command and let me install it. Okay, Helm install CSI secret store. Okay, and this is a release name and this is a Helm chat. Okay, you see that here, and this is going to be namespace to which we are going to install actually. Now let me click on enter. Okay, let it install actually. Okay, you see that we have installed secret store CSI driver to our kube system namespace. If you see kubectl get pods -n cube -system. If you go here, you see that here secret store CSI driver has been installed to our Kubernetes cluster, actually in the kube system namespace. Okay, that's how we do. Okay, the next part. This secret store CSI driver, what it does, okay, what it installs on our Kubernetes cluster. This secret store CSI driver installs some kind of custom resource definitions to our Kubernetes cluster. Actually, if you see kubectl get crd custom resource definition. Okay, so you see that here secret provider classes and all these things were installed. You can see that this one and all these things will be installed by the secret store. This two actually mainly. Okay, you can see that this one as and this one. These two are installed by the secret store CSI driver to our Kubernetes cluster. Okay, so these are something called custom resource definitions actually. So we have custom resource definitions and the custom resources in Kubernetes. So Kubernetes provides some kind of default objects like deployment, replica set or stateful set, all these things. But if you want to work with some additional such kind of management, additional functionalities which is not given to us by Kubernetes, you need to install CRDs, custom resource definition, custom resources. You can create custom resources with the help of custom resource definitions actually. So all these things are there with the Kubernetes cluster. That's what in the Kubernetes actually. That's what I initially mentioned. You need to have some knowledge on Kubernetes before doing this particular lab actually. So what it does, just as of now, remember one point, it installs some kind of CRDs on your Kubernetes cluster. What it installs means secret store CSI driver have installed some kind of CRDs to our Kubernetes cluster. Using these CRDs, we can create custom resources. Okay, we are going to create something called secret provider class. Okay, what is this secret provider class? It is a custom resource which is being created using this custom resource definition. And in this custom resource, what we need to do, I'll be telling you. Before that, go to your AWS account. Okay, after installing secret store CSI driver to the Kubernetes cluster, go to your AWS account, go to this, go to your secrets manager, go to this secrets manager. Okay, go to your secrets manager, open a new tab, this one, and click on this secrets and create a secret, store news, click on this store new secret. Now I am going to create other type of secret. Okay, so this is not the type credential using Amazon RDS. It's not a database like secret of RDS database and all. Other type of secret I'm going to use. I'm going to use a plain text and I'm going to remove this. Okay, I'm going to use SQL123 as a password I'm going to use. Okay, let me click on this next. Okay, so now I am going to use my SQL-CREDS is a secret name that we have in our AWS secrets, like secrets manager. Actually, we are going to create this one. Okay, contains. Let me give some description. MySQL password, something like this. Okay, let me click on next. Okay, now let me click on next. Okay, and let me click on store. Okay, let me click on refresh. Okay, you see that you have stored secret of MySQL in this particular place. If you see that we have stored secret in your secret store, like AWS secrets manager. If you click on this secret, you will be going to the secret value. You can click on this retrieve secret value. You are going to get the value that you have stored in this particular place. That's fine. Okay, now this secret which we have stored here has to be used by my MySQL pod. Previously, How it has been used? It has been used something like this by setting the environmental variable and by taking the value from the secret object of Kubernetes. Okay, so it should not be something like this now. The password has to be taken from the AWS account, AWS service of AWS Secrets Manager. Actually, the password has to be taken from the AWS Secrets Manager. Password has to be taken from the AWS Secrets Manager. That's what you need to understand. How our pod is going to get the permissions to take the password from the AWS Secret Manager. That was the point now. Okay. Our pod previously, from where it is taking the secret using traditional secret method, the pod is taking the secret from the secret object of Kubernetes. But now, from where it should take? It should take the password from AWS Secrets Manager. It should not take the password from the secret object of Kubernetes. It should take the password from the AWS Secret Manager because all the secrets are stored centrally in this particular place. Okay. Now, how my pod get the permission to take the password from this place actually? Okay. In order to get my pod permission, you should follow some process. Okay. What you need to do, you need to create an IAM role. Okay. IAM policy. Okay. Go to the IAM service of your AWS. Go to this particular service. Okay. Go to this IAM service. Okay. Click on this policies. Click on this policy. Okay. You need to click on create a policy and you need to give the service name to which service you are going to give the permission for your pod, right? To which service? It's a AWS Secrets Manager because our passwords are stored in the AWS Secret Manager and the pod should have the permissions to get the password from the AWS Secret Manager. So what is the password? What is the service that you need to select? AWS Secret Manager. What's the, you can see that Secret Manager. Okay, this is the one. Okay. Now, what permissions that you need to give? Read permissions only. The pod is only going to get the secret from the AWS Secret Manager. The pod will not update the secret in the Secret Manager. The pod will only just get the password from the Secret Manager. So that's why I am going to give all read permissions in a like this, something like this. Okay, I'm going to give all read permissions. Only reading the data from the secrets manager, but not writing the data, something like this. Okay, now I want to add some specific ARNs, something like this. Add ARNs. I want to give any region. I want to give any secret. Okay, and let me click on add ARN. Okay, now let me click on next. Now let me give some meaningful name. MySQL EKS secret store. Okay, MySQL EKS secret store. Actually, the description I want to give permissions for pods to get secret MySQL password from AWS secret manager. Okay, that's what this policy contains. What this policy contains? Policy contains the permissions for the pod to get the password from the AWS Secrets Manager. Okay, so that's what you need to understand. The password, the policy name is MySQL EKS Secret Store. Right? Let me copy this policy name. Okay, let me click on create a policy. Okay, you can directly create the policy using the commands in my README file. You can directly create a policy using these commands, but I don't want to create. I want to show you how we create actually, because you should understand that policy. Okay, how to create that. Okay, that's why I went to the UI and showed you how to create the policy. Now, you have to do two things. you need to install AWS provider to your Kubernetes cluster, and you need to create IAM OIDC provider for your Kubernetes cluster, because your Kubernetes cluster is trying to interact with other AWS services, right? Your Kubernetes cluster, like your pods in the Kubernetes cluster, your whatever the things in the Kubernetes cluster is trying to interact with this other AWS services. In order to achieve this, you need to do two things. One is AWS provider you need to install onto the Kubernetes cluster, and you need to configure your EKS cluster with IAM OIDC provider. Okay, so that your pods will be authenticated with the IAM service and get the permissions and get the permissions of the policies which you have attached and get and communicates with the AWS service actually. So like that it is going to be. For that, I am going to install AWS provider. Okay, let me go here and that install something called daemon set to our Kubernetes cluster. Let me enter it. Okay, and let me go here. I am also going to create this one IAM OIDC provider. Okay, you can see that this is my region where I have created EKS cluster, and this is a cluster name. Okay, UAT-dev. Okay, let me copy this. Okay, let me go here and put it here. Okay, you see that here I have did that one. Now I have did the things in order to use my AWS services by our pods actually. Now one more thing is left out. How my AWS pods will get the permissions to interact directly with the AWS Secrets Manager. You need to create a service account. You need to create there is a concept of service account. All these things will be coming under the security of the Kubernetes. Okay, please do remember that. Please do not confuse. Okay, that's why I mentioned some kind of information, some kind of knowledge is required for you in order to complete this lab actually. So you need to create a service account and attach the policy which we have created from the AWS UI to this particular service account. Okay, that's what you need to do that. Okay, so the policy is this one. Okay, let me copy the policy ARN which we have created. This is a policy, and we will be whatever you create in the AWS account, you are going to get an ARN. Copy that ARN and update the ARN in this particular policy, in this particular command, attach policy command. You need to update the ARN of the policy. And what you need to do, you need to copy EKS CTL create IAM service account. Okay, let me enter, let me copy this first. Okay, and apply it to the Kubernetes cluster. Okay, let's wait the cloud formation stack to be completed. Okay, you can see that my service account is deployed. Okay, if you see this kubectl get SA is a shortcut for service account. Okay, you see that this is the service account. Let me copy this service account name. If you go here, kubectl edit, yes, see, and the service account name. If you click on this one, you see that a role will be created. You can see that a role will be created when you attach a policy. You see that, let me copy this role name. Let me go to the AWS account and show you the actual what is happened. Actually, the policy which we have created manually will be attached to this role, and this role will be attached to the service account. Let me go to this role, and you see that let's it load. Yeah, you can see that this is a policy that we have used in order to do that. Actually, you can see that when executing this command, we have the policy ARN. You see that this is a ARN that we have used, right? So this policy ARN will be used by the Kubernetes and create a role and attach this policy to that particular role, and that role will be attached to this particular service account, and this service account will be attached to this particular pod of MySQL, so that MySQL pod gets the permissions to fetch the data from the AWS secret manager. Okay, so that's what I'll be showing you the diagram. Actually, do not worry about that. This is just a lab I'm going to show you. Okay, colon Q. Okay, you can see that a service account got created. Okay, now this service account which we have created has to be used by the pod of MySQL, so that pod gets the permissions to get the data from the AWS secret manager. But as of now, there is only one secret in the secret manager. One secret in the secret. If you see, only one secret name is there. One secret in the secret manager. Okay. So if you have multiple secrets in the secret manager, which secret need to be fetched? Which secret need to be fetched? That information where you need to give. Okay, that information you need to give in the secret provider class, which is installed as a custom resource definition. When you install AWS secret CSI driver to your Kubernetes cluster, okay, you will be installing this. You will be applying this secret provider class, and in this secret provider class, what you are going to mention. Okay, so in this secret provider class, you need to mention something like which secret that need to be fetched. Let me copy this secret name, and this is a secret name that you need to be fetching actually. So Control Z, MySQL hyphen creds. Actually, this is a MySQL hyphen creds is the secret name that need to be fetched from where it should be fetching secrets manager of AWS. And the alias means I'll be showing what is this alias actually, and who is the provider, who is the service provider is the AWS actually. That's why AWS is a service provider. Okay, in this secret provider class, what you need to mention? You need to mention where our secret is located. What is the secret object name and where it is located? What is the object alias? The file name which is attached to the pod. I'm going to tell you what is this, and you need to apply this one to the Kubernetes cluster. Okay, let me go here to this particular place. ls cd dot ls cd secrets with respect to CSI driver. Let me click on ls kubectl apply -f secret provider .yaml. Okay, you can see that here. If you see kubectl get secret, okay, kubectl get secret provider class providerclass. You see that this is a secret provider class that we have deployed, right? So now we have deployed the secret provider class. Now let me go to the deployment file now. Okay, this is the deployment file for our using the secret using AWS secret manager. Okay, you can see that here. Okay, I am using MySQL image, and you have an environmental variable that is called MySQL root password file. Okay, and we are going to use the service account which is created just now, which we have created just now. What is the service account? Service account is attached with the role, and the role is attached with the policy, and policy has the permissions to AWS secret manager to read the data from the AWS secret manager, and the service account which has these permissions will be attached to the pod directly, right? So how we have attached to the pod? Using this manifest file, using this service account name, MySQL creds SA. That's what the service account that we have deployed. Where is that? Okay, you can go here. Yeah, you can see that MySQL cred SA is the service account that we have deployed, right? So that service account, we are going to use it here so that the pod gets the permissions to get the data. And you see that we are going to create a volume. What is the volume here? We are going to mention in the volume that where the data need to be fetched. db-cred is the volume name and the CSI driver, and who is the CSI driver? Secret store CSI driver, and the read only, it should only read the data, and the volume attributes is something like what you need to provide the secret provider class name, so that only the data which is required will be fetched from the AWS secret manager, but not all the data. Okay, so you see that this is a secret provider class name that you need to be fetching actually. Okay, now this volumes which we have getting, you need to mount this volume to our pod using volume mounts block. In this particular case, actually, volume mounts to which path I am mounting the like mounting the data to MNT secret store is the path in which inside the pod I am mounting the data with this particular path, actually at this particular path. And this is the where object alias comes into picture. The fetched data from the AWS secret store, the fetched data from the AWS secrets manager, where it should be stored on this file. Where is that? In this file inside the pod. That's what we are going to mention, actually. Where we are going to mention here, actually, in the secret provider class MySQL root password in the object area. That's a file that will be used in order to store our data whenever the object is fetched, whenever the password is fetched from the AWS secrets manager. Okay, let me deploy this particular manifest file to the Kubernetes cluster. kubectl apply -f deploy.yaml. Let me click on enter. Okay, you can see that here. kubectl get pods. If you click on this one, it's in a container creating state. Let it fully load. You can see that it is in the running state. It is in the running state. You can see that this is a pod that we have just now created. Okay, now this CSA driver will not create any secrets. Okay, you can see that here. You can see that there is only one secret which is used previously by the traditional secret, that particular method, actually. But in this case, in the new fetching the secret from the secret store CSA driver, the password is directly attached to this particular pod, actually. Let me go inside the pod. Let me show you. kubectl exec -it pod name --/bin/message. First, let me go inside the pod. And where I've told you to where the pod will be storing the data in this particular path, actually. This is a file, and let me go to that particular path. Okay, and in this you will be having this one MySQL root password cat MySQL root password. If you see, this password contains SQL123. From where this has been fetched, actually, this has been fetched from the AWS secret store. You can see that from this particular place. You can see that get retrieve secret value. You can see that MySQL123. From this particular place, our data is fetched, and that is used by the pod and configure this one. Let me enter into MySQL database, MySQL-u root, okay, -p. What's the password that we need to use? MySQL123 is a password that you need to use. 1 second. So, -p, right? So SQL, not MySQL, SQL123, enter. You see that I have entered into the MySQL database like we have did previously using the traditional method. You can see that here we did, right, using the traditional method using this one. Okay, so now you see that here our secret object is not created. If you see get secret, our secret object is not created, but AWS secret store CSA driver is directly fetching the data from the AWS secrets manager and attaching that value to this particular secret as a volume to this particular pod, actually. And pod will be taking the data from this particular file from there, actually. You can see that here. This is a file name, from where the pod is going to take the data. Okay. So where is that file name? MySQL root password is a file name. Okay. Now, here, how the things are going on, how the things are working, first you need to understand. Suppose this is my Kubernetes cluster where we have installed some of the CRDs using Helm. Okay, using Helm, you have installed some of the CRDs. You have installed CRDs. Okay, and we have our AWS secrets manager out of our Kubernetes cluster, something like this, where this is AWS secrets manager. Let's think AWS secrets manager. Okay, AWS secrets manager. Okay, now what will be happening when you click apply this one? Okay, let me show you. when you use kubectl apply deploy.yaml, who will be receiving this instruction to deploy the pod to the Kubernetes cluster actually? Okay, there is a component called kubelet in the Kubernetes cluster. That kubelet component will be getting the instruction from the Kubernetes masternode components in order to deploy the pod. Okay, there is something called a component called kubelet. Okay, it will get the instruction to deploy the pod. Kubelet is a component that will be there in the Kubernetes cluster. It will get the instruction to deploy the pod. And when the kubelet want to deploy the pod, kubelet understands the pod requirements. Okay, it should have something called volume. Who will be creating this volume? Secret store CSI driver. As we have installed secret store CSI driver initially to the Kubernetes cluster, kubelet in the Kubernetes cluster will consult secret store CSI driver. Okay, secret store CSI. Let me write CSI driver in order to get the volume. DRI in order to create the volume, something like that. Okay, it will consult this one because kubelet first notices this particular volume block. Okay, this one, because we have seen who should create a volume, secret store CSI driver, and who need to fetch the data, secret provider class. Okay, you can say this is a secret provider class. Okay, let me go here first. Okay, now secret CSI driver, kubelet will consult CSI driver in order to create a volume. Okay, when you applied the manifest file. Now CSI driver will contact this secret provider class MySQL DB password. Okay, this is a secret provider class that we'll be having. Okay, this CSI driver will contact the secret provider class. There will be a secret provider class, secret provider class that we have installed, that we have applied just now, right? So we'll consult CLASS. Okay, this one CSI driver will consult secret provider class in order to get the data. And this secret provider class will be getting the data by connecting to AWS Secret Manager. And giving back to the CSI driver. And this one, a volume will be created with the data, and a pod will be created with that particular mounted volume by the kubelet. This is a volume. This is a volume. And this is a pod which will be mounted. Which will be mounted at path. What's the path that we have given in the pod? This is the path. This is a path, volume mounts path. The data volume will be mounted at this particular path inside the pod. And the pod and the MySQL database which is running inside the pod will be taking the data from the password from this particular path. Okay, this is how it does. This is how it does actually. Okay, this is how it does actually. Now let me do something like this. Something like this. Okay, AWS Secret Store CSA driver actually. Now, what is the use of advantages of using this Secret Store CSI driver? Okay, advantages of using this Secret Store CSI driver is you no need of having secret object manifest files, and you no need of pushing that secret object manifest files to the GitHub repository, so that your data will be in a secure place. Actually, your data will not be there as part of the manifest files, and the data will not be shown to other people who has the permissions to the GitHub repository where you will be storing your manifest files. The first disadvantage is gone. Okay, in case of traditional. Okay, now you will be having centralized place in order to store your secrets. Okay, and the third advantage that you are going to get is there will not be any secret object that is going to be created if you use this particular method in the Kubernetes cluster. What's the advantage of what? What is the advantage if the secret object is not going to be created? The people who has the permissions to the Kubernetes cluster, okay, the people who has the permissions to the Kubernetes cluster will not be able to view the secret data if the secret object is not created in order to configure your MySQL database. Okay, so that are the advantages that you are going to get in case of this particular things actually. Now we have seen the secret store CSI driver and lab we have seen and all these things we have seen. Now the thing that I have mentioned actually, I forgot to mention, so the entire lab is not completed yet. Now, suppose this password in the future, I had a requirement to edit it and I want to change the password. 456. This is a password that the database password has been changed, and now this is a password, this is a new password that need to be updated inside the pod. Okay, let me click on save because we are storing the secret value, password value as part of the secret store CSI driver, right? Sorry, AWS secret manager, right? So now the password has been changed and this password will not be changed inside the pod. The pod will be using the old password only. Okay, if you use this one, if you go to cd this particular place, cd this particular place, copy this one, paste this one, and ls cat mysql, you can see the mysql root password, you can see that SQL 123 only is there. Okay, you need to enable auto rotation. Actually, that is something called auto rotation, or let me fetch out the word exact word what we call actually enable secret rotation. You need to enable this particular secret rotation in order to whenever, why you need to enable the secret rotation actually, whenever you update the password in your AWS secret manager, the secret also will be updated within your pod actually. Okay, that is why you need to enable this one. Okay, if you want that particular functionality, you need to enable this one. If you do not want that functionality, if you delete the pod, again secret will be fetched and the updated secret will be fetched actually. So if you want to directly update the password without deleting the pod, you need to enable this one. How you can enable this one? Something like this. Okay, you will be having, you need to fetch out the values.yaml file of your Helm repository, something like this, values.yaml file. This is a values.yaml file, and you will be finding something called enable secret rotation. You need to make it as true, and you need to upgrade your Helm release that is there on your Kubernetes cluster. Helm upgrade, this is the one, and you need to use this one, and you need to apply this one. Actually, you can see that here. Exit out of this pod, and you need to see Helm list -n cube -system. Okay, you can see that here. Okay, you can see that this is the secret store CSI driver is the release that we have deployed, and you need to upgrade this one by this particular command. You are going to use the updated values.yaml file. See, these all the things are Helm related things actually. Okay, do not worry about this. Okay, we have updated the secrets to the Helm release. If you see Helm list -n cube -system. Okay, you see that here revision is 2. Okay, previously revision is 1. Okay, that means our Helm release has been updated. That's the meaning of that actually. Okay, now let me go inside the pod. It takes, the default time is 1 minute. Actually, it is going to take 1 or 2 minutes in order to update the password inside the pod. As of now, let me go inside the pod actually. Let me go to cd this one. Okay, go here and cat mysql root password. Okay, cat it. Okay, it is still SQL 123. It should be changed to 1234566 because we have updated the password in the AWS secret manager, right? 123456, SQL 123456, right? Let me go here. Let it do automatically. You delete the pod, a new pod will be created using the updated password only. But I want to show you how to do how the pod can do automatically. it will be doing. Just wait for a minute. Come on. Yeah, you see that here. What's the password now? SQL 12345 6. How it is being changed? Because we have updated the values.yaml file and we have updated the Helm release version. Helm release actually by updating our values.yaml file. And the password is now configured with our Kubernetes database. Sorry, MySQL database inside the pod is with SQL 12345 6. Okay, we did not delete the pod. The pod is same running previously, and it is been uh, auto refreshed actually. kubectl get pods. You see that it is running since last 15 minutes. The pod will not be deleted and the data will be automatically fetched. The updated password will be automatically fetched from the AWS secret store, secrets manager, and update inside our pod actually. Okay, that's how we need to enable the uh, auto rotation of the secret, auto enable rotation. What is that? What's the word actually? Enable secret rotation actually. So that's how we do actually. Okay. So this is how we use AWS Secret Store CSI driver in order to store the secrets centrally and securely in our real-time projects actually. Okay. So any questions, anyone, please? I hope it's a tough lab because you need to understand some concepts of Kubernetes and Helm in order to do this. That's what I mentioned previously. Okay. So anyone have any questions? Did you get the lab actually? So
Sir, why
yeah.
are we mounting as a volume, sir, normally? That secret, why are we doing this as a
No,
volume?
using this secret store CSI driver, right? You cannot directly use the environmental variable. You cannot use MySQL root password and attach the value from the secret store. You cannot do something like that. Okay.
Okay.
So we are mounting the volume because let me go here to the deployment file. Okay, we are going to mount the volume because we are going to make the secret available inside a file inside the volume. Okay, that is why we
Okay.
are going to mount a volume to that particular pod, and we are making the pod to take the password from that particular file which is mounted actually. So have you
Okay.
got that point? Okay, that's how
Yeah,
we are doing that. Yeah.
Yeah. And every time, whenever we want to use the secret, we want to give its location, that object location, sir, in secret provider YAML. Like
Yes,
if
yes, in
new
the
secret.
secret provider class, right? So you need to
Yeah.
give the object name because there will be multiple secret objects that can be present right in this particular place. Okay, you need to
Yeah.
specify which one you want to fetch out. Okay, so you need
Okay.
to provide the object type, and the object alias is the file name, which that it is the file name which will be this one in which
Okay.
your password will be stored actually. Okay.
Stop. And in secret manager, no duplications will be allowed. Only one. Like we
Yes, yes,
cannot
you
have.
cannot
Yeah.
have
Multiple.
multiple
Yeah.
secret with the same secret name, right? So yeah.
Yeah. Yeah. Got it. And there is one more pod identity, something like that, right, sir? Can we use that for IAM? Like rather than creating IRSA, can we use the pod identity?
Yeah, you can use. See, you can have multiple options, right? So
Yeah.
whatever feasible, you can use that in order to achieve the permissions. See, ultimately, you need to have the permissions to get the data
Okay.
from AWS Secrets Manager, other services in the AWS Secrets Manager. Whatever the process used, that's
But is
our
there
restriction, right?
anything
Yeah.
like industry standards or something like that? Because pod
We use
identity,
this one
this.
actually.
Okay.
In our company, we use this particular way, IAM service account, creation of service account, attaching the IAM role, and we will be
Okay.
attaching the policy to the IAM role actually. So that's the thing.
Okay, sir. Yeah. Thank you, sir.
Yeah. I hope you people got the lab, but yeah, I hope how the session is. Okay, just want to know. understood or not, or because there should be some topic that it will be known before this lab. Yeah, as this is seminar, I cannot explain all the things, but yeah, I've explained what I can actually. So yeah. Okay. For your information, we are having some course from DurgaSoft. And that the course is all about the Docker, Kubernetes, Jenkins, and AWS. Okay, we are going to have all these topics as a single bundle of course. Okay, that course is going to be started tomorrow, 9 a.m. If you are interested, please check out that, and we'll meet. And we are going to discuss many real-time scenarios like this, how we use secrets, like how we have discussed today actually. And the course will be not directly like this, not directly discussing the Helm how we discussed in today's session. First, we are going to discuss what is Helm, what is a values.yaml file, and what is a Helm release, and what is a Helm chart. Okay, how we add that Helm chart to your local repo. All the detailed explanation will be there, not something like this, because as a seminar session, I cannot explain all those things. In the course, everything will be explained very, very clear and uh, very, very practical manner actually. Okay, tomorrow is a demo sessions that will be conducted. If you are interested, please to attend the sessions, and if you are interested, you can also join the course actually. Okay, that's the thing. If there is a Durgasoft website actually, durgasoft.com. You can go to the website and check out the course details actually. Okay, and thank you everyone. In such a weird time, you have given some time to meet in order to attend the seminar. Thanks for everyone. If you have any questions, you can ask any questions, please. Okay. If no questions, thanks for joining. And please check out, we are going to conduct a regular seminar, something like this every Sunday. Please do check out that one, and please do attend the seminars. In the next seminar, we are going to discuss entirely about the EKS cluster, what is node groups, managed node groups, and the target profiles, and what is an EKS, and from the basics of EKS. Actually, first I want to give entire overview of EKS. Actually, we are planning that in the next seminar. Just check out that, and please do attend that. Okay. Thank you. Thanks everyone for joining the session, and we'll meet in the next class. Any questions?
Thank you. Thank you, sir. Thank you.
Thank you. Bye.